This video is about the concept of an inverse. And specifically, we're going to be talking about the inverse of a function. This video will be mostly an introduction, and we will talk more in depth about what functions do, or what inverses do in class. Here's our basic idea. The inverse of a function undoes the original function. Or we could say, the inverse of a function undoes whatever your original function did. Okay. We'll give an example of what that means in just a second, but first I want to talk a little bit about notation. We've been working in class with functions that were named f and g. So how do we write down the inverse of these things? Well, it looks like this. And I want to make it clear, this is not saying f to the negative first power, or f minus 1. Right? How do we say these things? If f is our original function, then this is what we call the inverse of f, or we could say f inverse. If our original function is g, then we call this g inverse, or the inverse of g. Right? And we've had things like this in class. Right? And what is this? This is the output of f, or we say f of x. Right? So if you see something like this, how do we say that? Right? Well, this was the output of f. This is the output of the inverse of f. Right? Or you could say, this is f of x, this is f inverse of x. Okay? The idea is this is the output of the original function, this is the output of the inverse function. Alright, so let's talk more about this idea of inverses undoing each other. And we'll go back to our example of function machines. So imagine I have a function machine f, and I also have an inverse function machine, f inverse. Right? So imagine I have this function machine and I were to input 3, and the output is 5. Well, what does that mean for the inverse function? The inverse function undoes this. Or what that means is, if I were to input 5 into the inverse function, well, the output would be 3. Right? Because if I inputted 3 into the original function, I get an output of 5. So to undo that, if I input 5 into the inverse function, I get an output of 3. Right? Or if I were to input 7 into the original function and get an output of 9, well, for the inverse, that would mean if I input 9, I get back 7. Right? It just undoes what the original function did. Okay? In function notation, how would this look? Right? So for this first function machine example, in function notation we would say f of 3 is 5. Right? And so for the inverse function, f inverse of 5 is 3. Right? Or in other words, if we input 3, then we have an output of 5. Right? So it's just the inverse, right? The output of our inverse function when we input 5 is going to be 3. Right? Similarly here, f of 7, if f of 7 is 9, then we can say for the inverse function, f inverse of 9 is 7. Let's take a look at an input-output table. So some input and output values of a function are shown below. And we want to think about, what does this tell us about the function's inverse? Right? So let's say we have this g function, and here we have inputs, and we have some corresponding outputs. Right? I want you to actually pause the video right now, and I want you to think about, what do we know now about the inverse of g? So please pause and see if you can write down what you think we know about the inverse of g. All right, well, here's what we know. Right? If we have an input of -3, which gives an output of 8 for the original function, well, for the inverse function, if we inputted 8, we would get an output of -3. Right? And similarly, if I input 5 into the original function and get an output of 4, well then, if I input 4 into the inverse, then I should get an output of 5. Right? And I can do these just the same. And once again, in function notation, we would say something like this. Right? Let's look at these first inputs and outputs. Right? I would say something like this. G of -3 is 8, or in other words, the output of the original function when we have an input of -3 is 8. And that means that g inverse of 8 is -3. Or in other words, the output of our inverse function when we input 8 will be -3. Okay, we're going to look at one more thing. We're going to talk about inverses with graphs. So right here, the graph of h of x is shown here, right? And that's important. This is h of x. It's not h inverse. But let's see if we can use this graph to find these outputs, right? And look carefully. This is the output of not h, but the output of the inverse of h when we have an input of 1. Okay? So you might be thinking, I don't know how to do this because I don't have the graph of h inverse. Right? But what we do have is the graph of h. Okay? And I want to just think about what we just did in the previous slide. Right? We were able to think about both of these input-output tables at the same time. Right? And I'm just going to use letters for the sake of an example. If I inputted a into the original function and got an output of b, well, for the inverse function, that means if I inputted b, I would get an output of a, right? Because they just undo each other. So let's think about this. What are we asked to find here? We're asked to find the output of the inverse of h when we input 1. Right? In other words, 1 is the input into our inverse function. Well, what would that mean for our original function? It would mean that 1 was the output. Okay, so now let's think about that. Where in our graph of h of x do I have an output of 1? Right? Well, I have an output of 1 right here. Right? That point is 3, 1, right? Which means that h of 3 is 1, or the output is 1 when we have an input of 3. So I can fill out my original table here. When I input 3, I get an output of 1. So what does that mean for the inverse? Well, when I input 1, I get an output of 3. So h inverse of 1 is 3. Okay. I would like you to try these two out on your own, and we will look at the answers and see if you got it in class.